Hello everyone, Devashish again from Dev's Learning Hub. So this is our second class on ogive and histogram. Ogive already I have covered. In my first class, what is ogive, less than ogive, more than ogive. Clearly I have explained the concept along with practical example and the utility of ogive. Here we are going to explain what is histogram, what is the use of histogram. Then how we can use histogram to find out the mode for grouped data or continuous data, and then how to find out mode using histogram even for discontinuous data. The first thing is you need to understand histogram. Let's start. So histogram is actually used to represent the grouped data or continuous data. First of all, I will explain you what is histogram. As I said, for histogram, the objective is to give a pictorial representation or graphical representation of continuous data, so that you can look into the graph and you can easily interpret what kind of data it is, right? Okay. So we are utilizing this data set to make you understand exactly how this data set will be look like graphically or pictorial representation, how it looks like. So to plot the data, we are along the x-axis it is class interval, it's representing class interval. Along the y-axis it is representing frequency. So the scale I have used here 10, 20, so each interval is 10. Along the x-axis 10, 20, 30 up to 80, because the value it is 20 to 80 you have. Lowest observation value 20, highest observation value 80. And why it is continuous data? Because 20 to 30, then it is 30 to 40, then from 40 to 50 there is no gap. It's a continuous data, right? So, and along the y-axis, the lowest one frequency is 2, highest frequency it is 11. So I have assumed 5, 10, 15, each of the interval, that is 5. Here each of the interval it is 10, right? Along the x-axis. So now I will plot the data. So 20 to 30, this class interval 20 to 30 has the frequency 4. So how you will plot it like? So 20 also has 4 and 30 is also has 4. That is let's say this is the data point, that is 4. Okay, so what you will have 20 you have 4, 30 also you have 4, so 20 to 30 it looks like this, 4, 20 to 30, right? So 20 to 30 that looks like 20 to 30. This class interval has the same frequency, that is 4, right? It's like a rectangle, right? Now, from 30 to 40 it is 7. So if it is 5, let's say this part is approximately 7. This one is 7, right? Now, 30 to 40 you have 7. 30 it is ends here. So 20 to 30 it is 4. 30 to 40. 40 is also 7. So 30 to 40 you have 7. Right? So then 40 to 50 it is 9. Let's say this one is 9, just below 10. This one is 9. So now, so 40 to 50 it is 9. It is 9. 40 and 50 is also 9. So 40 to 50 this class. So 40 to this is the entire, this green is representing 40 to 50. 9. Right? This black 30 to 40 is represented by this part. 30 to 40 it is 4. And 20 to 30 this one is this one. That is for 20 to 34, for 30 to 47, 40 to 59. Then 50 to 60 it is 11. 50 to 60 it is 11. Let's say this one is 11. Actually, we will plot all these things in a graph. Here, just on eye estimation, I am doing that just to make you understand. So, actually, while you will do it in the graph, you should utilize multiple color if possible, right? So, 50 to 60 it is 11. So that means 50, it will extend this part here. So it's a continued, you can say 30, it ends here for 20 to 30. Again the 30, there is no gap along the x-axis, right? And so this is what, this one is 50 to 60. Right? Again 60 to 70 it is 6. 60 to 70 it is 6. 6 means, let's say this one is 6. $60 to 70. $60 to 70, there is 6. 70 to 80, there is 2. If it is 4, let's say it is 2 is here. 2 is here. So 70 to 80, it is 2. So now, let's say the table is not given to you. This is what the historical histogram, that is what the representation by the histogram. That means, and the y-axis, along the y-axis, you have the values, along the x-axis, you have the class intervals. So 20 to 30, you have the frequency 4. 30 to 40, you have the frequency 7. 40 to 50, you have the frequency this one. So it intersects the y-axis here, that is 9. 50 to 60 intersects the y-axis here, that is 11. 60 to 70, this one, 60 to 70, this one intersects here, 6. And 70 to 80, either you will be asked to represent the entire data set into histogram form, or you will be given graphically the x-axis and y-axis values and the intervals. You need to find the tabular form, how the data, continuous data. So either from the table, you need to form the tabular, to write in a tabular form, or the tabular form is given with the continuous data set, you need to generate the histogram. Both the ways it can be. So this is what histogram it looks like for continuous data, and it is used to give the graphical representation of continuous data set. So now you have understood what is histogram, right, and how you can represent any continuous data set or the group data versus frequency in graphical representation, right? So now I will show you how you can determine the mode for continuous data or such group data using histogram. Okay, so now from the tabular data itself, you can easily see, like when we identify median for a continuous data set or group data, we first find out the median class, in which class the actual median point belongs to, right? So similarly, from the table itself, you can easily see that the 50 to 60, this class or this class interval has the highest level of frequency 11. So therefore, from the tabular data itself, you can understand the mode will come between 50 to 60, but what will be the mode? And from the histogram, let's say you don't have the tabular data as such, then from the histogram, just by looking into the histogram, how you can find out the mode, you will find out the mode in which class the highest frequency belongs to. So the highest frequency here in the curve, in this histogram, we can see the highest frequency belongs to this 50 to 60 because this is the highest rectangle you have. So the highest rectangle, that is the frequency 11 and the class interval is 50 to 60. Here in between 50 to 60, the mode will be there. Now what is the mode? There is a trick to find out the mode. To find out the mode, what you need to do for the highest rectangle, right? You need to draw the diagonal from the leftmost corner of the highest rectangle to the next rectangle corner. So this is what? The diagonal. Another diagonal you need to make, that is from the rightmost top corner, rightmost corner at the top, for that highest rectangle to the previous rectangle right corner. So left corner of the highest rectangle to the next rectangle leftmost corner, and rightmost top corner of the highest rectangle to the rightmost top corner of the previous rectangle. So this diagonal, these two diagonal, where this is intersecting, this is the point where basically the mode belongs to. Therefore, to find out the mode, what you need to do, you need to draw the perpendicular from this intersection point on the x-axis, and where it will intersect x-axis, this point is the mode. This point is the mode. So this is the intersecting point of two diagonals. From this point, intersection point, you need to draw the perpendicular on the x-axis, that is on the class interval, and where it will actually intersect, this point is called the mode. Here, by eye estimation, if I see 50 to 60, this is the gap is 60, here it looks like around 53 because it is less than half, 55. So it will be around 53 or 54, but the actual measurement you will have when you will put all this data in the graph paper, right? So that is how you need to determine mode for a continuous data set or group data using histogram, right? Okay, now I will tell you one more thing. Let's say there is discontinuous data set, but you need to find out the mode. How will you do it? For the histogram, you need to make sure that you need to have the continuous data set. 20 to 30, 30 to 40, 40 to 50, there is no gap. But let's say there is a table like this. Let's say the value, instead of 30, let's say the table looks like this. Now let's say the next data is set is 20 to 30 class interval. Look into the class interval. 20 to 30, then not 31, 30 to 40, it is 31 to 40, then 41 to 50, then 51 to 60, then 61 to 70, and then 71 to 80. So the upper bound of the previous class and the lower bound of the next class interval is not same. So there is a gap, right? So this does not look like a continuous data set. So how you need to adjust that? So the difference we can see, 31 minus 30, it is 1. 31 minus 30, 41 minus 40 equals to 1. So everywhere this gap is 1, 50 to then 51, 60, then 61, 70, then 71. So in that case, what you need to do is there is a specific trick on that. What you need to do, you need to identify what is the gap. So the gap between lower bound of the next class that is higher than the upper bound of the previous class. Always the lower, and the gap is always same. 31 minus 30, it is 1. 41 minus 40, it is 1. 51 minus 51, 61 minus 61, and similarly 71 minus 70, it is 1. Everywhere the gap is 1. In that case, what you need to do, you need to divide this gap into two parts. There is 1 by 2, that means 0.5. So what you need to do, once you identify you divide that gap into two parts. That value here, it is 0.5, that you need to deduct from each of the lower bound and add with each of the upper bound. That means how does it look like? 20 minus 0.5, that is 19.5 up to 30.5. You need to add 30.5. 31 and 40, that means minus 31 minus 0.5, 30.5, 40 plus 0.5, 40.5. So 30.5 to 40.5. Similarly, (40.5) to 50.5. 51 to 60. 50.5 to 60.5. 60.5 to 70.5. And 70.5 to 80.5. So that means everywhere the class interval was 10, but the upper bound and lower bound between two class intervals, these two are not same. But the class interval everywhere it is 10. So here also, after deducting 0.5, that is the adjustment factor. This is called adjustment factor. So you find out the gap between the lower bound of the next class and the upper bound of the previous class, and then you divide that gap. If this gap is everywhere it is equal for all the class interval, then you need to divide that gap into two parts, and then that is called adjustment factor, and that adjustment factor you need to deduct or subtract from the lower bound for all the class interval and add with the upper bound of all the class interval. Then also you see that 19.5 to 30.5, or the height is 10, 30.5 to 40.5, 10. 70.5 to 80.5, 10. So class interval remains same, but now the data set is continuous. 19.5 to 30.5, 30.5 to 40.5, 40.5 to 50.5. So for all the class interval, the previous class interval lower bound is equal to the previous class interval upper bound is equal to the next interval class interval lower bound. 30.5, 30.5, 40.5, 40.5, 50.5, 50.5, 60.5, 60.5, 70.5, 70.5. Now your data set is continuous. Then you accordingly you place the data in the graph and find out the mode. So you need to convert the data set into continuous data, even though it is discontinuous. Another situation could be, let me show you for the discrete data also. For discrete data, we don't need to find out the mode using histogram. Straight away you can look into the number of occurrences, highest number of occurrences for the observation value, and that observation value will be the mode. But if you are asked to find out by giving some finite values and find out the mode using histogram, that also you can do. And for all the discrete values it is not possible. If for all the discrete values gap is same, then only you can do that. Let's just do it. Let's say there are a set of values, discrete values given like this, 20, 30, 40, 50, 60. You are asked to find out the mode using histogram. If you are just to find out the mode, you can straight away do it like this. For 50, it has the highest frequency 11. Second row is frequency, first row is numbers. So second 11 is the highest frequency for which observation value 50, so 50 is the mode. But if you are asked to find out the mode using histogram for this data set, how will you do that? Because histogram you need continuous data set, the class interval, right? Continuous data set or the group data. Here it is not a group data, you need to form a continuous data set or group data. How will you do that? If the difference between each number is equal, that means it's an AP or arithmetic progression. In that case, the difference, similarly in the last example, in the last case what you have shown you, what you need to do, what is the gap? 30 minus 20, 10. right? 40 minus 30, 10. 50 minus 40, 10. 60 minus 50, 10. So here it's an AP series or it's an arithmetic progression. So the difference which is equal with respect to arithmetic progression, the common difference, you need to divide that common difference or divide that difference by 2. So 30 minus 20 equals to 10. Your adjustment factor will be 10 by 2 equals to 5. So now once you have found out the adjustment factor. This is adjustment factor AF. This adjustment factor you need to subtract and add. Subtract and add. That means it should be the 20. You subtract adjustment factor 15. 20 minus 5, 15. To 20 plus 5, 25. So 15 to 25. Next one is 30. So 25, 30 minus 5, 25. 30 plus 5, 35. So class interval we can see it is 10. Right? Next is 40 minus 5, that is 35. And 40 plus 5, that is 45. 50 minus 5, 45. 50 plus 5, 55. 60 minus 5, 55. And 60 plus 5, 65. So now it's a continuous data set. Let's see. 15 to 25, 25 to 35, 35 to 45, 45 to 55, 55 to 65. Now whatever is the frequency, the same frequency it is there. 4, 7, 9, 11, 2. But you can find out this problem, the mode for this data set. If you are asked to find out the mode using histogram, you can do that because you have the continuous data set. Because that is the primary condition to draw histogram where you will have the continuous data set for group data. Even though your data is grouped, but it's not continuous, in that case, you cannot draw histogram. Because in histogram, you can see between two class intervals, there is no gap. It's a continuous data. That is why it looks like this. Adjacent rectangle. There is no gap between two rectangles. So these are the three things I was supposed to explain today. What is histogram? Histogram is the graphical representation of group data for continuous data set. If it is continuous, then you can straight away plot that class interval, right? And the frequency, and you can draw like diagram like this. And once you have the continuous group data with continuous data set, then you can find the mode in this manner. As I said, the diagonals you will draw, and then the intersecting point of that diagonal. From there you will draw perpendicular on the x-axis, and where it will intersect, that is that value is the mode for that group data set or the continuous data set. But if your data set is not continuous, then in that case you need to find out the difference between upper bound and lower bound, and you need to divide. If this is equal everywhere, then you need to divide that difference by 2 and find out the adjustment factor. What the resultant value is, the adjustment factor. That resultant value or adjustment factor you need to subtract from all the lower bound for all class intervals, and you need to add that adjustment factor with the upper bounds for all the class intervals. And similarly, even if you have the discrete data set like this, there is no group data, then also if you are asked to find out, only if you are asked to find out using histogram, then only you will apply this. Otherwise, you can straight away just look into this, you can find out what is the mode. Mode is 50. But if you are asked to find out using histogram, then you need to convert that data into continuous data set. How will you do it? You will find out the difference. If all the differences are same, you need to find out the difference and divide that difference by 2. Then that is the adjustment factor. Then you need to subtract for each of the values. You need to subtract that adjustment factor to find out the lower bound, and add the adjustment factor to that value to find out the upper bound. Then you will get the class intervals for each of the numbers. So then you can see it's a group data with a continuous data set, and then it's the similar way you can find out the histogram, and you can find out the mode also. Okay, so I believe now this is very much clear. I have explained ogive in my last video, and here I have explained histogram. You can find out what is the difference between these two, what are the utilities of ogive and histogram, and in histogram how to find out the mode for continuous dataset or discontinuous dataset or discrete data, right? So if you liked it, please click on the like button, and if you are really interested to have this kind of video again and again to clear your fundamental ideas, please subscribe my channel. Thank you very much.